Deduplication is a process you run for a selected viewpoint and node type to detect and flag potential duplicate nodes. A viewpoint can end up with duplicate nodes when you have inadvertently added similar nodes with different names by importing from multiple data sources. By importing from a single data source where duplicates were not resolved before importing, or from users submitting multiple requests using different names for similar nodes. Deduplication is similar to the process of matching and merging, where matching and merging is a proactive process that resolves duplicates for nodes that exist in a request before they are committed to a viewpoint. Deduplication is a reactive process that resolves duplicate nodes that have already been committed to a viewpoint. Because viewpoints can potentially contain millions of nodes, deduplication uses one of two methods to filter which nodes in the viewpoint are evaluated for matching. Time-based deduplication matches nodes that were created on or after a selected date and time. Cluster key deduplication uses an indexed property to group nodes into clusters and performs matching on a single cluster at a time. For the node types that you want to deduplicate, a metadata manager must add the CoreStats created date property to the node type and configure a clustering property for the node type. When creating matches, deduplication uses many of the same elements as matching and merging request items. Matching rules configured for deduplication are used to identify potential duplicate nodes. Survivorship rules control how properties and relationships are merged after a match is confirmed. And matching stopwords can be configured to ignore common words such as the and company from being used. The matching workbench is used to accept, reject, or skip the match candidates, and to decide how the accepted matches should be merged. Before you can run deduplication on a viewpoint, a metadata manager must create matching rules, survivorship rules, and optionally a list of stopwords for the node type. See our related video for more information. To run deduplication on a viewpoint, a data manager first creates a request or opens an existing request. They then create and run deduplication for a node type in the viewpoint. They review the matching candidates in the matching workbench and accept or reject the matches. The data manager then applies the changes. The system uses the applied changes to create request items in the request. Delete actions are added for duplicate nodes, and property insert, update, and move actions are added to the surviving nodes based on the survivorship rules. Finally, the data manager submits the request, which can optionally proceed through an approval process or be immediately committed. The source nodes that match existing target nodes are deleted from the viewpoint, and information from the deleted nodes is merged to the surviving nodes. Let's see how deduplication works. Say you are a data manager who maintains a master list of customers that other users update on a regular basis. You run a periodic deduplication on the viewpoint to identify and correct duplicate nodes. For example, when I search for Anud, I can see two customers with similar names that use the same stock exchange symbol. Checking the created date for US Anud devices shows that it was added most recently. The Links tab reveals that this node was merged into the customer list viewpoint from our lead management system. Inspect the node type to view matching rules. The customer node type has one deduplication rule for the master customer list viewpoint based on the name property. Let's review the rule definition. This rule creates matches by using the similar to operator to perform a fuzzy search on the node name. The optional prefix length specifies the number of characters at the beginning of the string that must exactly match. Matches with a match score of less than 20 will be auto-rejected. Unlike rules for matching and merging request items, deduplication rules do not support an auto-accept threshold. There is also one survivorship rule defined for the viewpoint, which determines which property values are copied from the source node to the target during deduplication. For example, the value for the assets property is copied from the source node to the target, but the company name property is not. During the deduplication process, you can override survivorship rules at the property level for each match result. Finally, we have defined a list of stopwords to ignore when matching against the name and industry properties. Stopwords affect all types of matching operations performed for the node type. Let's run deduplication on the viewpoint. Start by creating a new request. Select the Match and Deduplicate tab, then click New to select Deduplicate Viewpoint. Select the viewpoint and node type that you want to deduplicate. Because viewpoints can potentially contain millions of nodes, you generally deduplicate them in batches. The deduplication mode is the first way to define a batch of nodes to match. Select Cluster Key to use an indexed property to group nodes into clusters. The customer nodes in this example have a clustering property, Industry. For example, I can select Asset Management to deduplicate only customers in the asset management industry. Alternatively, select Time-Based to match nodes that were created on or after a specified date and time. I'll select Time-Based for this example. Optionally, specify a batch size to limit the deduplication batch even further. For example, if either match mode still returns thousands of eligible nodes, you can enter a smaller batch size to process at a time. Running the deduplication processes the first batch of nodes. In the matching workbench, you can then continue deduplicating the next batch until you have processed all nodes that match the mode criteria. After selecting your options, you run deduplication to show the results in the matching workbench. The summary section shows how many nodes in the batch had matches in the viewpoint and how many did not. In the deduplication results section, matched nodes, the nodes that you are evaluating during the matching process, are shown with their match candidates underneath them. For each match candidate, the match rules that apply to the candidate are displayed, as well as the match score for the rule. The match score represents the confidence level of the match candidate, as indicated by a numerical score and a colored meter bar. Select a match candidate to compare its properties to the matched node in the deduplication details section. During deduplication, matched nodes become the source nodes that are deleted after the merge operation, and match candidates become the target nodes that survive after a merge. These deduplication results show a number of name matches across industries for companies using the word international in their name. To help you verify or disprove matches, you can use the locate icons to view either the source or target node in the viewpoint. In this example, Zinc International is definitely not a match for Atkins Pearson International. Before continuing, let's add international to our list of stopwords. In the Node Type Inspector, select the Rules tab, then select Stopwords. I'll edit the stopwords for the name property. Return to the Match and Deduplicate tab. The original deduplication results are still displayed. Select Rerun to reprocess the existing result set with the new stopword. Notice that match candidates with international in their names are now filtered out of the results. Now let's evaluate matches for potential duplicates. At the bottom of the list is US Annude Devices Inc., which has two potential match candidates. Inno Devices Inc. has a relatively low match confidence score of 32. Review the deduplication details to evaluate the match. Notice that the stock symbols don't match. I'll reject this match. Annude Micro Devices has a much higher match confidence score of 65. Reviewing the details shows that the industries are different, but the state and stock symbol are the same. I'll accept this match. After accepting a match, the deduplication details show how properties will be merged based on survivorship rules. Use the radio buttons to override rules for a property. Just because a match result has a low match score doesn't mean it's not still a match. Let's locate the source node in the viewpoint. Notice that Allied Banking Interchange Incorporated was added from the lead management system, which uses the customer's stock symbol as its primary identifier. Returning to the match results, notice that although the names don't match, the state and stock symbol do. I'll accept the match. For this match, I'll use the source value for the industry and the target value for the founding date. Atkins Pearson International has 2 potential match candidates. Let's check the first, Atkins. Notice the matching stock symbols. I'll accept the match. You can't merge a source node to multiple target nodes. Accepting one match candidate automatically rejects other candidates. I'll change the state property to the source value. Let's skip the next match. This leaves potential duplicates as they are, to be matched and resolved later. When you apply changes, the system creates request items and removes the accepted matches from the deduplication results. You can continue working on the deduplication results until you submit the request. Now let's review the request. For each of the 3 accepted matches, the system created 2 request items, one to edit the target node with the merged information, and one to delete the source node. Requests have an item limit of 10,000, so only 5,000 matches can be processed in a given request. I'll submit the request to commit the changes. Now when I search the viewpoint for a node, only one node exists. To learn more, visit docs.oracle.com.